In Unit 1, we were mostly working with primitive data types, which are integers, doubles, booleans, etc. They're usually represented with all lowercase letters like this, and their values are stored directly in memory. So in the case of this variable here, which I will call num, and we'll have 13. The value 13 itself is stored as a binary representation in the computer's memory. In other words, 13 itself is saved. There is another type though that we did touch upon in Unit 1, but we didn't explore as much as primitive types, and they are called class types or reference types. Strings are an example of them. So I will make a string variable here, and we will call it Sam. All right. So in the case of Sam, the variable has a memory address, and this memory address points to where the data is kept. This is important, as if we are making reference to a string, we are not making reference to the variable itself, but rather the memory location where the data is saved. But what if, as in this example, we make two strings pointing to the same thing? In this case, we have our first string that we made earlier, which points to Sam, and we have this other one pointing to name? What does that mean? Well, when we have two strings like this, or in more general cases, two class types like this, a copy of the memory address is created, meaning instead of both of them being Sam, they are two copies of the same memory address pointing to the word Sam. So if we want to print them both, which we will do on one line, so we will have name plus a little space plus our second variable other name. Let's see what we get. That's a lot of exclamation mark. As you can see, they are both Sam. This is very similar to how primitive data types work as well. However, the underlying difference that you don't notice is how they are stored in the computer's memory. And that will become important later on, so keep this in mind. And don't worry if this concept doesn't make much sense at the moment, as we will touch upon it more in other units to come. It's also important to know here that when we change the string to something else, instead of Sam, we'll do Samantha, a new string is generated in a different memory location than before. Now, with all that being said and done, let's talk about this. As you can see, I have declared a variable, but I have not initialized it to anything. So if I were to print the variable out, what would we actually get? Let's find out, shall we? As you can see, we have an error. Now let's see what the error actually is. Variable string might not have been initialized. There we go. And it even points to where it is, which is right here. This is the variable that we have not initialized yet. So is there a name for this? Why, yes. Right now, our variable is null. In other words, it doesn't refer to any value. It's pretty much meaningless at the moment. Obviously, we can change it to something like our little name from earlier, Sam. But as of right now, if there's no initialization, the variable is considered null, which, by the way, is a keyword that we can even set the variable to if we wanted. And if we print it out, it will actually be null and there will be no error. So to anyone taking the AP exam, by the way, it's probably not best to set your variables to null unless you really need to for a very specific purpose. So all I'm saying is, please read the question. Pumpkin!